Today you're going to practice graphing a quadratic equation. The vertex of a quadratic function or parabola is the minimum point of a positive quadratic function and the maximum point of a negative quadratic function. A parabola is symmetric with respect to the vertical line called the axis of symmetry of the parabola. This line is found with the formula x equals negative b over 2a, where a is the coefficient of the x squared term and b is the coefficient of the x term of the quadratic equation written in standard form. You can find the maximum and minimum by plugging those a and b values into the formula and solving for x, but a lot of the time it's not necessary to use the formula at all because it's very easy to see the axis of symmetry right from the graph. So that's what we're going to practice with more today. So taking a look at example number 1, we have the equation y equals x squared, and we're going to graph that equation. Notice they gave us a domain to graph it over. Remember, whenever they give you a domain, you're only going to graph point to point. You're not going to extend with arrows. So for this first equation, we're going to pull up y equals x squared in our calculator, even though it's simple enough to do without a calculator. And pull up the table. And since we have negative 3 to 3, we're going to only look at those points on the calculator. So we have negative 3 is positive 9. We're going to start graphing those points. Negative 3 and 9 is our first point. Then negative 2, 4 is our second. Negative 1, 1 is our third. Don't mind my multiple dots because it's not lining up perfectly, but you get the idea. 0, 0 is the next. 1, 1 is the next. 2, 4 is the next. And 3, 9 is the next. Now, as we read in the directions, we talked about the line of symmetry. You can see just within the dots that this shape is going to be symmetrical. So now we're going to connect dot to dot, not extending, even though it would definitely go up in both directions if we continued, and we can see that right from our table. And here we have a quadratic equation or a parabola. Parabola is typically the shape of a U, like this one, and it would extend up in both directions with opposite sides being symmetrical to each other. So we want to find the turning point or the vertex as well as the axis of symmetry. So the vertex is this bottom point right here. So it's what we call a minimum in this case because it's at the bottom, and it is 0, 0. The axis of symmetry in this case winds up being the y-axis because that's the line that you would fold both sides of the parabola over to have it be symmetrical, have each point match up. So the axis of symmetry is just x equals 0. Okay, very simple to graph. Let's take a look at the next one. For number 2, again, notice that the same domain is given to graph over, negative 3 to 3. So I'm going to go back to my calculator, go back to y equals, clear what's there to begin with. And I'm going to enter negative x squared plus 4. Pull up the table. And again, negative 3 to 3 is what's shown up on my calculator because I had it there before. I noticed just from here that I need to get as low as negative 5 and as high as positive 4. So I'm going to set up my x and y axis so that all fits on the coordinate plane since it's not given to me. So my y-axis can stay right in the middle. My x-axis I want to be a little bit lower. I know I need to get, or a little bit higher. I know I need to get up to 4 and as low as 5. So as long as you have 5 boxes below and 4 boxes above, you're good. Now we can go ahead and graph. -3, -5 is our first point. -2, 0 is our next. -1, 3 is our next. 0, 4 next. And then the opposite side, it starts to go down. But is symmetric to the points we just graphed. And graphing point to point because I was given a domain. I see again that I get a parabola, but this time it's what we call a negative parabola because if the lines were to extend, they'd be pointing downwards. So now we don't have a minimum vertex, we have a maximum vertex. Because it's at the top, it's the highest number. And the maximum vertex is 0, 4. And from that, we get our axis of symmetry, which is the x value in the vertex. So our axis of symmetry is x equals 0. Again, because the y-axis, again, acts as the axis of symmetry. And on the y-axis, x is equal to 0. I'm going to do one more graph with you, and then you're going to try a couple on your own. So number 3, again, we go back to our calculator. We're going to clear out the y equals. And we're going to enter -x squared plus 2x. And pull up the table. And this time we see that we want a domain of -2 to 4. So we only want to graph from -2 to 4. So I'm going to show that in my calculator screen. And from there, I see I need to go as low as -8 and as high as +1. So I'm going to place my x and y axis accordingly. I see on my x-axis, I only go to -2, but I go over to +4. So I can think about maybe moving my y-axis if I needed to. So I can draw my y-axis a little bit to the left of center. And my x-axis has to be up pretty high because I only have to go up to +1 and down to -8. And now I can start graphing my points. So we have -2, -8. Then -1, -3. Then 0, 0. Then 1, 1. Then 2, 0. You can see we're going back down. So we already passed the turning point. 3, -3. And 4, -8. Again, only graphing point to point because I gave you a domain to graph it over. So now we can see that this, again, has a maximum point because it's a negative parabola. And this maximum point is up here. So it has a maximum vertex. This time the vertex is not on the y-axis, and that is okay. The vertex is 1, 1. So from that, we see that the x value is 1, and that is also our axis of symmetry. So that's all the things you can learn from a parabola. Again, parabola is the same as a quadratic function. It has a maximum point if the parabola is negative. It has a minimum point if the parabola is positive. And within that maximum and minimum point, we get what's called the vertex. And from the vertex, we get what's called the axis of symmetry, which is the x value of the vertex. So you're going to go ahead and do the rest of the notes on your own, answering the questions in the Go formative as you go. Please make sure you ask me if you have any questions.